Okay, good morning. Let's start the session. The start of the session, first we will discuss how to install the particular Python IDLE. Okay, we have many different tools where we can execute the Python. Now I will show you one way. Simply go to the Google python.org. This is the place where the Python software is freely available. Python.org. Press enter. So this window is open. In this, go into downloads. Simply go to downloads. So observe Windows, Mac OS, other platforms. That is whatever the operating system you are using. Depending upon the operating system, you can select. Suppose right now I am using Windows operating system, and then simply click on download for Windows. Download for Windows. Okay, again I am repeating. First go to python.org. Python.org. So whenever we are going to python.org and then move to the tab downloads. Under downloads, depending upon the operating system. For example, if you have Mac OS, select Mac operating system. These are the different versions that are available, not only a single version. You have many number of versions, whatever the version you want. So you can select that particular version. You can select that particular version. Similarly, if it is Windows, again Windows also we have many number of versions. Okay. So at the top corner by default it will show the latest version. Simply click on this one. See this one. Whenever you click on this one, it will start downloading. After that, you know the procedure. What is the procedure? How to install a software in your system? The procedure is very thing. Simply click on this one. So actually in my system, already Python is available. That is the reason it will shows these things. Suppose if it is not available also, then you can click on this one, install now and customize installation. For example, if you click on install now, simply you have to press yes and then move on and then move on. Okay, simply click next. Automatically the software is installed. No need to do anything. After clicking of the download, press next. The finally the software is installed. After that what you have to do, how to open and how to execute the programs. Simply go to the start or go to the start and IDLE. It is saved as IDLE. Okay, click on this IDLE. So this is the screen open. Okay, now here you can perform your operations. Here you can perform your operations. Simple operations also. 2 plus 3. So automatically addition is performed. Automatically addition is performed. Press enter. The answer is 5. 2 into 9. The answer is 18. So like this. Suppose the previous one, hello world. So it prints hello world. You got the meaning? So this is the place we are executing the programs. But remember one thing, after completion of one line, if I press enter, then automatically moves to the next prompt. So if you want to write multiple lines at a time, then you will move to file, new file. Here we can write the program. Here you can write the program. Suppose, don't observe the meanings. A is equal to B is equal to 6, C is equal to A plus B, print C. You got it? This is my program. So I am using two variables, A with a value 5, B with a value 6, C is equal to addition. That is first to perform A plus B and then the result is assigned to C and then print the value of C. The basic thing, print the value of C. First we have to save the program, Control S, or in the file we have saved. It automatically select the path. No need to do anything. Whenever you are installing Python software by pressing next, everything is done by the system only. You no need to do anything. For example, here it open the path and in this folder the my program is saved. For example, program name is SAM dot. No need to use dot also. Actually, if you want, you can save the Python program with .py. Remember that thing? If it is a C program, saved the file with .c. Java. Similarly, if it is Python program, you have to save the program is .py. Okay, here you have to write .py. Even though you are not writing .py at this position, not a problem. Why? Here already selected save as a type of Python files. Save as a type Python files. Okay, automatically it will consider as is a Python file. If you are providing, not a problem. Save. So the program is saved and then run the program. So click on run and then run module. Click on this run module. See this one. Again, the answer is displayed in this page. Again, the answer is displayed in this page. Okay, the answer is 11. Now, in this IDLE, not only in this IDLE, generally, this Python software, that is the tool where we are executing the Python programming, contains two modes. Contains two modes. One is interactive mode, second one is script mode. There are two modes in Python. One is interactive mode, second one is script mode. What is mean by interactive? We directly interacting with this page. So this is the screen where we can directly interacting. Here we are providing the input, we are directly getting the. So this is called interactive mode. In interactive mode, directly we are giving the input. By pressing enter, we got the output. Another one is script mode. Script mode in the sense this one. So where we are writing the script. Script is our program. So script mode in the sense where we are writing our original script, and whenever we are writing the program in script mode, you have to save the file with .py. In interactive mode, no need to save. But in script mode, you have to save the file with .py. Remember the thing. Remember the thing, even though you save the file with .py and it execute, again the output is in interactive mode. Again, the output is in interactive mode. Okay, this is one place where we are executing the Python program. So right now this is only required because we are whenever we are moving into advancements of Python, then only we require some other Anaconda, Jupyter, PyCharm, Pylabs, etc. etc. So right now we are in basic situations. That is, we have to learn the concepts of Python, and this ideally is sufficient. So first I will move with ideally. Whenever we require, I will explain how to install and how to use the next tool also. Okay. Now coming to our regular topic. Now the thing is data types. Generally, what is mean by data type? First, I will explain the concept and then I will show you the execution, how it happens. Okay. So data type specifies the type of data stored in a variable, that is called data type. Okay, so the type of data. So remember the fact, in all the languages except Python, first you have to declare the variable. In the yesterday class also we discussed. First we have to declare the variable. For example, like this, int a, float b. Then what happens? A is an integer variable, so A can store only integer value. B is a float variable, B stores only float values. But in Python, this is not required. No need to declare the variable. No need to declare the variable. Whenever we are assigning a value, depending upon the type, The variable becomes that particular data type. See this one, based on the value provided, the type will be assigned automatically. So no need. For example, if I am writing a is equal to 5, a is automatically becomes an integer variable. B is equal to 4.3. B becomes a float variable. No need of any declaration. So that is the reason we already discussed Python is dynamically typed language. Dynamically typed language. First, we will move to int data type. Int data type. For example, a is equal to 10. Integer in the sense all whole numbers. Integer in the sense all whole numbers are called integer. A is equal to 10. So a is equal to integer. And one more function. This is a predefined function. The Python contains many number of predefined functions. One more predefined function is type of. Here the variable. So what is the output? So it specifies, that is the output is what is the type of the variable. Depending upon the value that is that are present in the variable, it displays the type. For example, a is the integer variable. Here the type is class int. That is, here a is of type integer class. Of type integer class. This is the basic thing. The basic thing. Now, in generally in programming languages, we are using four types of values. We are using four types of values. Even though we have many number, but in programming languages, these four are the most useful things. One is decimal, second one is binary, next to octal, and next to hexadecimal. So see what is this one? What is mean by decimal form? Any number with base 10 is called decimal number system. For example, if a number is with base 10, what are the possible numbers? Very simple thing. Whatever the base we are considering, 0 to base minus 1. These are the possible values. Why? If you are dividing any number with 10, the possible reminders are 0 to 9 only. So, if a number is of decimal form, the possible digits are 0 to 9. For example, a is equal to 235. This is a decimal number. Observe, the digit is in 0 to 9. It is in 0 to 9. It is also in 0 to 9. Each and every digit is in between 0 to 9. Then that is called decimal number. Here there is no conflict. By default, up to now, whatever we are using, everything is called decimal. Whatever we are using, everything is in decimal format. Okay. Now coming to binary. Binary in the sense 2, base 2. If you are dividing any number with 2, the possible reminders, for example, consider number 4. Divide number 4. 2 2s are 4. Remainder is 0. Suppose number 5. 2 2s are 4. Remainder is 1. Observe whatever the number we will take. If you are dividing the number with 2, the possible reminders are zeros and ones. The possible reminders are zeros and ones. So generally, a binary number is prefixed with 0b. If a number is prefixed with 0b, then only this is a binary number. Here 0b 101. This is a binary number. 0b11. This is a binary number. 0b001. This is a binary number. Anything combination of zeros and ones. But see this one here. It contains 1, 2, 3. This is not a binary number. You got it? That is invalid. That is invalid. Next one is octal number. Octal in the sense base 8. If it is base 8 in the sense, the possible literals are 0 to 7. Now one simple straightforward thing is A is equal to 235. Observe here the digit 2 is between 0 to 9, at the same time in between 0 to 7. This is also. Now the question is whether the 235 is a binary, sorry, octal number or decimal number. There is a conflict. You got my point? So if the numbers, if any digit is between 0 to 7, that is called octal number. In the same sense, that is also called as decimal number. That is also called as decimal number. Now, what to do? Simply to provide the differentiation between the decimal numbers and octal numbers, by default, every number is considered as a decimal number. If any number prefixed with 0, remember the first one is 0, second one is O. If any number prefixed with 0 O, then that is called octal number. So 0 O, 1, 2, 3, this is octal number. Suppose 0, if it is prefixed with 0 in the sense it is not an octal number. You have to check the digits also. So digit 7 is okay, digit 6 is okay, but digit 8 it is not possible. Only allowed digits are 0 to 7. So this is invalid. You got it? Now, hexadecimal. Decimal in the sense 10, hex in the sense 6, hexadecimal in the sense base 16. So the digits are, the possible reminders are 0 to 15. But we can write only 0 to 9. How can you write from 10 to 15? For example, if you are writing 10, system it will consider as 1 and 0, not 10. That is the reason to store the values of 10, 11, 12, 13, 14, 15. So these are represented by using the letters A, B, C, D, E, F. You got my point? For example, if my assumption is some A is equal to 915. 915. How the system will consider this is 9, this is 1, this is 5. But my intention is this is 9 and this one is considered as 15. But it is not possible. Why? Each and every individual digits is considered. That is the reason to represent. If your value is 15, instead of 15, you can write 9F like this. Here, the letters A to F are in either uppercase or lowercase. Either uppercase or lowercase. They are differentiated based on every hexadecimal number is prefixed with 0x or 0 capital X. If you are prefixed with 0 small x, that is in lowercase. Prefixed with 0 capital X, that is in uppercase. That is the output. C 0x F A C E. It is okay. B E E F. This is okay. B E E R. This is an invalid. This is invalid. Okay. These are different types of integer numbers. Now the thing is conversion. Suppose if I am given an integer number to you, or that is a decimal number, how to convert into a binary? The general procedure is, if it is my decimal number, observe, this is my decimal number, the normal without any using mathematical functions. How to convert into the binary? Two 10 jars to, sorry, okay, two 11 jars. Two 11 jars 22, the remainder is 1. Two 10 jar, two 5 jar, two 5 jar 10, the remainder is 1. Two 2 jar 4, the remainder is 1. Two 1 jar 2, the remainder is 0. Now the store the answer in the reverse direction. 10111. This is the binary representation for 23. Simple thing. If I am given any number to you, any decimal number, if you want to convert into binary, divide with 2. Suppose if you want to convert into octal, divide with 8. Divide with 8. 8 to 2 are 16. The remainder is 7. So it is not possible to divide 2. So simply the answer is 27. Similarly, if you want to convert hexadecimal, divide with 16. Divide with 16. Or you can use the functions like this. Suppose simply bin of A. Assume A is equal to some 23. Bin of A, automatically the number is converted into binary. Oct of A, the number is converted into octal. Hex of A, the number is converted into hexadecimal number. Not only a decimal number, whatever the base we are given, any base is converted into hexa by using hex function. Now, first I will cover all the topics and then move to execution. No problem. Float data type. Float in the sense real values. Float in the sense real values, that is a number with decimal point. See this one 1. Here 1 is called integer part. One is called integer part. This dot is called decimal point. 234 is called fractional part. So this is the decimal number. Generally, the decimal sorry, this is the floating number. Generally, the floating numbers are represented like this. Now, along with this, we have another way that is exponential form. That is exponential form. In exponential form, we are using the notation E. This is the way. What is the meaning of this one? Here 1.2 is called mantissa. Technically, 1.2 is called mantissa. 3 is called exponent. This is practically this one 1.2 into 10 cube. That is the answer is 1200. So point 0. Okay. If you want to represent a number, suppose representing the number like this, it is somewhat difficult. For example, like this, many number of zeros. It is somewhat difficult to overcome this one. We are using this E. Here E is either capital or lower, either uppercase or lowercase. And one more thing is if you are writing 1.2 E minus 3 is also the meaning is 1.2 divided by 10 cube. 1.2 divided by 10 cube. That is simple thing. 1.2 into 10 power minus 3 into 10 power minus 3 in the sense 1 by 10 cube. Now, fine. One more thing is complex
Sorry
data type. This
to
is
interrupt.
our yes, please.
Can you repeat the last slide once again? I
Okay.
couldn't get it.
Okay, okay. No problem, no problem. Yes, this one. Okay, I'm erasing this one and then repeat. For example, if you have real numbers, we have to represent the real numbers in the mathematical or in the programming, whatever it is. So floating numbers is called real numbers. Generally, every real number must and should contains this decimal point. This decimal point here 23.56. Assume this is a real number. In this generally this 23 technically this 23 is called integer part. 23 is called integer part. This 56 is called fractional part. 56 is called fractional part and this point is called decimal point. This point is called decimal point. This is the way to represent floating point numbers. For example, if you have very small numbers, it is very easy to represent. Assume if my number is 23 0 0 0 0 0 0 like this point some 53 whatever it is, whether it is a 53 or 00 whatever it is, if my number is like this. For example, for simplicity I am using this one. Somewhat difficult to represent this number, so after point only 10, it is somewhat difficult to overcome this one. For real numbers, we have one more notation, that is exponential notation, or also called as scientific notation. In exponential notation, instead of representing the large number is represented by using small notations, by using that symbol E. E is called exponent symbol. Here you can write like this 23. Suppose consider the number E 1, 2, 3, 4, 5, 6, 7. Simply write like this. 23 is 7 or 2.3. You can write like this. 23 is 7 or 2.3 EH, whatever it is. You can write in any fashion. For example, if you are writing 23 E7, the meaning is 23 into E specifies 10. 7 specifies the power 10 power 7, or you can represent 23 E8. This is 2.3 into 10 power 8. So 1 point with 1 power both are cancelled. So that is the representation. Here you can use either lowercase or uppercase. So the main advantage is you can represent the big values in less memory, big values in the less memory. So this is the simple example, but actually we are not using. To be frankly speaking, in our programming, there is no chance to use this one. We are generally use only this one. Actually, these are the things that are used by the scientists. In their applications, they are using. That is the reason they are called as scientific application. Why? In the sense, in scientific applications, every millisecond is also countable. Millisecond is also countable, and that is the reason instead of representing the large decimal floating point numbers, they are using this exponential. To be frank, it is not at all useful for us. Yes. Now, I think that is okay. Complex data type. So first two are our regular values. For example, normal values without any point, oh, those are called integers. Values with real points, those are called floating. And we have another type complex. This is available in Python. Any number is of the form a plus bj. I think this is the this is in first year mathematics, first mathematics. So a plus bj, if any number of the form a plus bj, these numbers are called complex numbers. These numbers are called complex numbers. Remember, a is called real part. In this, a is called real part, b is called imaginary part. B is called imaginary part. Here a and b are either integer values or floating values. There is no restriction. A and B are either integer values or floating values. So in the real part, suppose coming to real part, we can use either a decimal number, octal number, a binary number, or hexadecimal number. That is, we have, for example, if you are trying to use an integer, we have different types of integers. That is either decimal integer, octal integer, binary integer, or hexadecimal number. We can use any type of integer in the real part, but remember, in the imaginary part, you are allowed to use only decimal number, only base 10 numbers. This is the restriction. Okay, for example, like this 2 plus 3j. Here 2 is the decimal, 3 is the decimal. 2.3 plus 3j. 2.3 is a floating, 3 is an integer decimal, not a problem. You can use any combination. Suppose 0 O 2 plus 5j. So this is an octal number. This is an octal number. This is the decimal number. 002 plus 005j. This is not allowed. In the imaginary part, only decimal numbers are allowed. Other than decimal, no type is allowed. No type is allowed. Okay. So how to get the values? By using, suppose this is my example. C is equal to, if you are writing dot, C dot real, automatically the value at real part is displayed. C dot imaginary, IMAG, the value at the imaginary part is displayed. Okay. No problem. Each and everything I will execute after completion of this slide. After completion of this slide, I will execute each and everything. Boolean data type. This is one of the additional thing. It is not available in C programming. Boolean contains only two values. Remember, Boolean contains only two values, true and false. True and false. Okay. True is represented generally, if 1 is represented as a true, 0 is represented as false. 0 is represented as false. Suppose if B is equal to true, what is the type of B? So it is a Boolean. Consider this example. A is equal to 10, B is equal to 20. Here my condition is A less than B. What is the answer? A less than B, in the sense we are checking whether A value is less than B or not. Suppose if A is less than B, answer is true. Now C can store the value true. C can store the value true. Okay. Now I will explain up this one. First, I will explain all these things. Move to ideally. I will close all these things. Yes. Now, first one is integer data type. Suppose a is equal to some 45. How do you check the type? TYPE, type of A. It displays whatever the value present in that particular variable, it displays that particular type. So, type of A is equal to integer. Suppose B is equal to 4.5. B is equal to 4.5. Type of B. Type of B. So B is of type floating. B is of type floating. See this one float. Suppose C is equal to 2 plus 3j. 2 plus 3j. Now type of C. Type of C is a complex number. See this one? Type of C is a complex number. Now, D is sorry, D is equal to true. Either true or false. Remember, the first letter is the capital letter. First letter, that is the T, is the capital letter. Suppose if you are writing true, see this one. Observe the color. The color is in black color. Generally, the predefined keywords are in different color. Predefined keywords in different color. Observe here. Print is in one color. Hello world. This is one color. Type is one color. These are the predefined functions. Generally, these predefined functions are in one color. So true, this color, type of D. Okay. So the first step is completed. I am reading four variables. I am reading four variables. Each variable stores different value. Based on the value, it takes the data type. Here, no need of any declaration. No need of any declaration. Now the thing is coming to integers. Coming to integers. Now A is 45. A is a decimal number. A is a decimal number. Suppose E, A1. This is my variable. You already discussed identifiers. Begin with an alphabet and can contain the digits also. Now, A1 is single variable. Remember, it is not two variables. A1 is a single variable. A1 0 some 45. 0 some 45. In this case, A1 is an octal number. Whenever we are typing the variable, remember, if you are typing the variable, simply the value present in the variable is displayed. See, what is this 37? Actually, here I am printing 45, but it shows 37 only. Why? Why? Why in the sense, I will show you. I will show you. So what is my number? A1 is the variable which stores the value 45. Suppose if you are printing A1, by default everything is converted into decimal. If you are trying to print the value, it does not print in octal format. It will print in only decimal format. So I already discussed how to convert an octal number into decimal number. Simply divide 45 with base 8. If you want to convert octal into decimal, so division. If anything is converted into decimal, divide with that particular base. So 8 with 45. So 8 5 jar, 8 1 jar 8. I think everyone know the basic logic. Okay. So I think you got it. So simply 8 1 jar 8, 8 2 jar 16, 8 3 jar. So simple logic. Simply 8 4 jar 32. And then remember that thing 8 5 jar. We have to divide up to the last worst case. Last worst case. Simply we know that one, the basic 8 5 jar 40. And what is the remainder? 5. So the number is 55. Here, what the number? 0045. It is 37. Uh, 1 second. 8 5 are 40. The remainder is 5. For example, 55. 5 into 10 8 power 0 plus 5 into 8 power 1 45. This is my answer. 45. This procedure is okay. This is correct procedure. One second.
But
I
you
will.
said it's octo, no? Octo means I think we should divide by 7.
No, no, no. Octal in the sense, octal is 8.
Okay.
Actually, octal is base 8. Hexa 6. Octal 8. Mm, yes. Okay, whatever it is, actually, this is my answer. Originally, the answer is I will explain what happens there. I will explain. Suppose 0045, the procedure to convert into decimal is this is fixed. The procedure is same, fixed. Divide with 8. 8 5 are 40. The remainder is 5. For 5, there is no need to divide. Simply the decimal number is 55. Simply the decimal number is 55. Check whether it is right or wrong. This is the decimal representation. Simply division 5 into 8 power 0 divided plus this 5 into 8 power 1. So 5 8 jar 40 plus 5 into 8 power 0 is 1. This is 45. So exactly this is the correct procedure. Exactly this is the correct procedure. Suppose according to you, if you are dividing with 7, 7 6 jar 42, the remainder is 3. Here also the answer is not true. 63. Here also the answer is not true. Actually, they are doing some another procedure. So I will see that one, what happened, ignore that one. But the procedure is only this one. Suppose let me check. A is equal to A is equal to 37 oct of A. Okay. Actually, they are using this procedure. So according to their logic, according to whatever the inbuilt program, 45. So okay. So octave is the function which is used to convert into anything octal number. For example, 37 is my decimal number. So octave 37, it is converted into 45. It is okay. But why it is shows 7? I think this is the right procedure. Actually, this is not related to Python programming. This is related to mathematics. Okay. Actually, this is Python programming. Okay. Whatever. Hex of 37. So 37 is converted into hexadecimal format. 37 is converted into hexadecimal format. If you are representing a hexadecimal prefixed with 0x, in octal number prefixed with 0o, and bin of 37, it is converted into binary format. Converted into binary format. Binary format generally prefixed with 0b. Binary format prefixed with 0p. 1.2 E3. See, converted like this. 112 E4 like this. 12 E4 like this. Suppose if I am representing, so like this, whatever the number you are writing, exactly. For example, if you are using this one, and one more thing, 1.2 E minus 3, it is represented in power. It is represented in the power. Now, C is my complex number. C dot real, it displays the real number. C dot imaginary, it displays the imaginary part. It displays the imaginary part. 0 to 22, whatever it is, plus 3j, it is fine. So this is converted into decimal. This octal is converted into decimal. Okay. So if my octal number is 45, So answer is decimal 37. It is right. But why my procedure is wrong? So since the octal number only uses the digits, first to arrange the octal number with the power of 8. We evaluate all the powers of 8. Oh, shit. Exactly. Exactly. Sorry. I am using the reverse one. Actually, this is related to mathematics. I said that one, not Python programming. So I am using the reverse procedure. The reverse procedure is A is equal to 0045. If you want to convert octal into decimal, then you have to multiply with 8. You have to multiply with 8. Actually, I am performing division operation. So in terms of 8 power. So first one 5. 5 into 8 power 0 plus 4. 4 into 8 power 1. What is the answer? 4 into 8, 32 plus 5 into 8 power 0. 8 power 0 is 1. That is 37. I think you got it. Actually, this is the way to convert. Exactly, I am doing the reverse procedure. I am doing the reverse procedure. Now, I think it is clear. For example, if you want to convert the decimal number into octal number, then you have to perform division operation. You have to perform division operation. Suppose 37 is my decimal number. So 37, 8 4 jar 32. 8 4 jar 32. The remainder is 5 and simply the answer is 45. This is the decimal number. It is okay? Yes, this is the way. So the only thing is here we are performing reverse operation. And remember one more thing, the most important thing, all these things are not at all useful for you. Okay, just for clarity purpose, I am explaining this one. These things are not useful for you. You only require the things octave. Here, whatever we are passing, that is converted into octal. Hexaf. Here, everything is converted into hexadecimal. Binaf. Here, the thing is converted into binary. You need to remember only the three functions. For example, octave, octave, like this 0x34. See this one 0x, it is an hexadecimal number. The hexadecimal number is converted into octal number. Suppose hex of, so 56 is the decimal number. The decimal number is converted into hexadecimal number. Suppose a is equal to, you can use the variables or you can directly pass the values, whatever it is. A is equal to, this is my number, hex of a. See this one? This is the hexadecimal representation of my number. Hexadecimal representation of my number. Okay. Suppose A is equal to 00567. So see this one? At the time of conversion, it will take E also. For E in the sense of 14. If at any time if you want 14, then the 14 is represented with E. So these are different data types. Remember, actually, this is the basic class. That is the reason I am explaining all these basic topics. Once we go on with this section, all these basic things are not at all necessary. In this entire session, you have to remember only 3 points: octave, hex of, decimal of, sorry, octave, hex of, bin of. Only these three things are very, very important. And then how do you represent a complex number and how do you represent a Boolean variable? In Boolean variable, we are representing true or false. In this, T is a capital letter and at the same time, F is also a capital letter. T is capital letter, F is a capital letter. You got it? This is the thing. Okay. So by today, I already said up to this week, we will close it to 7:20 only. Okay. From the next week onwards, we will move it to 7:30. Okay. Hope this session is clear.
Request to share the recordings in the group either by link or something. So we
Ah,
can
yes, yes. Everyday record. Yes, yes, sir. Yes, yes, sir. Everyday recordings are available. Actually, Swapna madam, every day send the recording. Please ping some message in the group. Madam, definitely send all the recordings. It's already
okay,
recorded. Already recorded.
okay, okay. Thank you.
Okay, thank you. Thank you very much.